welcome back. In this video, we will go over a nice scenario that just helps you to understand how to configure basic security. For example, we have R1, R2, and we have a ASA firewall, Cisco ASA. We could pretend that R1 is our office building and R2 represents the internet, or it could represent another building, or it could represent just another business altogether. Either way, your security will kind of be the same way. And I have everything set up nicely here. Routers, none of them are configured. The firewall's not configured. So we will start right away. Let's just configure the host name so we know what we're talking about. This is R1. And if you look at the drawing, G00 is connected to ASA G00. In order to keep track of everything so it's easier to understand, let's use a 10 dot network on R1 between R1 and ASA1 G00. So this is our internal network. This is what we trust. So, like I said, to keep tracking purposes, let's do this IP addressing 10.1.1.1.1 and 24-bit mask. No shut. And I'll jump back and forth between devices and just set Cisco as the password. Config T, no. This will be interface G00. I'll continue using all ones for this so that it's easier to keep track. So this firewall will be a .11 on that interface. Now, in firewalls, you need to specify their role, if you will, which is identified by the name if command. We do a question mark. It doesn't tell you much, just tells you a word. But Cisco ASAs have three different default, you could call them. It's inside, outside, DMZ. Of course, you could call it whatever you want. But if you specify those three, it's like a macro that runs in it. So if I say this is my inside network, watch what happens. It automatically sets my security level to 100. 100 means full trust. If I set this to, and let me no shut it first and give you the example on G01, which will be your outside network because this goes to untrusted. Let's say this is, like I said, the internet, another business, another building. We don't want to trust everything just right off the bat. So let's address this one with the twos. 10.2.2.22, 255.255.255.0. Let's give this the name if outside. The firewall is smart enough to know. Look at what happens. Security level set to 0. Think zero trust, which is the terms that we use now in security. I will no shut this. We'll go to router 2. Let's make sure we give it a host name of R2. Interface G00 is the connection back to the firewall. And this is 10.2.2, and we'll put 255.255. Remember, this doesn't necessarily equate to what you would do in production. You might have certain rules for IP addressing. Most companies have certain rules for IP addressing, and this is just for tracking purposes. Now you know 10.2.2 is the outside network. You know 10.1.1.1 is the inside network. Easy to track. It's router R1, 10.1.1, R2, 10.2.2.2, etc. Okay, now that we have that configuration there, let me exit out of here. One thing I want to show is that your Cisco ASA could work in two different modes. It's called either routed mode or transparent mode. by default, it will run in routed mode. What does routed mode mean? It means that R1 knows that this is a hop away. One hop and it gets to this network. Transparent mode would mean that R1 and R2 are not aware of this firewall. It's just transparent. Traffic flows direct as if these two devices, R1 and R2, were directly connected. In routed mode, we have to specify, we configured it. R2 is the 10.2.2 network, R1 10.1.1, which means since we are not running any routing protocols, we have to, in order to, from R1 to get to R2, we have to specify a static route. So we're routing that full 24-bit network. What is our next hop? Our next hop is the ASA because it's running in routed mode. And the first option is the IP address. So we have to specify to get to 10.2.2 24-bit mask. To get here, we have to go through G00. G00, remember, we configured as 10.1.1.11. That's it. But we have to do the same on the way back. We don't have to do it on the firewall because these are directly connected. The firewall knows the IP addresses and networks that it has. So on R2, remember, we're getting to R1 10.1.1.0 24-bit mask. We're using GI01, which was 10.2.2.22. Does this mean now that R2 can get to R1? Let's try. Ping 10.1.1.1. And no, remember, zero trust. Does that mean that R1 could ping out to 10.2 to the outside? Let's see. And it can't. Even though it's fully trusted, it still cannot go outside. So we need to configure an access list on the firewall. It's pretty much the same as a router. Like I said, it's just like a router. Access list. Let's call it outside, just so that we know what it represents. Access list outside. We're going to permit, and let's just permit ICMP, and we're going to do any, correct? And that should be it. Now with the firewall, we have to specify an access group, which works this way. And this is outside. We're going to allow it in, and we have to specify the interface. If you look at this, these are the ones I configured. So we're going to allow it from the outside interface in. And that is it. Okay. So now, are we allowed to ping across? We were successful. So if I do a show run access list, you could see access list outside extended, permit ICMP any. this was applied to this interface. So any traffic coming in on this interface will be permitted. Can R1 ping that way? Remember, we didn't apply the access list to this interface at all, only on this interface. Let's see, let's ping 10.2.2, and we are successful. Now, why is that? Well, remember, this is 100% trusted, and it's going outbound. But let's make a quick modification on this so that you could see how granular you can get. So here we have our access list, but suppose that we do not want to allow, if you recall, with ICMP, you need to send an echo, boom, 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 comes through here, and you need the reply, do. Now here is the issue. Since R1 is fully trusted, R1 has always been able to send the echo out. But because we did not allow ICMP coming through from R2, the replies were denied. So if we start configuring this, if we do an access list, in outside, we're adding another entry. We are going to permit ICMP any, but we're going to specify one of these entries. You can allow echo or echo reply. So what happens if we only allow echo? Let's pretend that. Allow echo. And that's it. And one thing that you have to be aware of when you create an access list like this, you're just adding an entry. So if I come back here, show run access list, now you see we have two entries. So I have to remove this one because, as you know, access lists are processed top down. So I'm going to remove that entry. Okay. If we run the same command, show run access list. Oops. Because we can do two. We can do group or we could do access list. So look at the group so that you see where it's applied in interface outside. So we're still good there. Show run access list. Now we only have the one entry. So could R1 ping R2? Nope. Could R2 ping R1? Yep. Why is that? Because we're only allowing echo. Remember, everything is trusted from R1 out. Full trust. R2 in, zero trust. But we are allowing echoes to go through. And that is the issue, but that's not what we want. That does not make any sense because we don't want R2 to have more power or access than R1. So here's what we're going to do. What we want to do is we want to allow replies to come from them. Basically, we don't want R2 to be able to start hunting and see if they could ping us. But if we ping them, we do want to take their replies. Okay. So the way we do this is access list outside. It has to be the same name. Permit ICMP any, but we only want the echo reply. Okay. And we need to remove this one because every time you add an entry, it gets just added to the bottom of the access list. So no, we don't want the echo. Okay, and now let's do a show run of our access list. I always have a problem with that dash, and there we go. We are only allowing echo reply. Can this guy, can R2 ping now 10.1.1? Nope, cannot. Can R1 ping R2? Yes, because we are allowing the replies to come through. So this is a way to kind of have a basic security. It's not a big deal, but it's probably something that you want from the get-go. You never want the external world to be pinging your internal network, but you want to have the ability to ping the outside world. You want to, that's part of your testing, part of troubleshooting, and everyone. So behind R1, you might have 1,000 different computers. You might have a help desk, you might have a NOC, you might have just so many different users. And in order for them to do their job, they might need this type of access list, this firewall entry. But you wouldn't allow the outside world to just ping whatever they want. I mean, they could start doing reconnaissance work on you now. They could do so many different things to your network just from allowing pings. So it's kind of a nice little introduction to firewalls, to the ASAs, and you can just keep playing around with this and seeing how it works for you, and keep practicing, keep building scenarios, keep doing it as much as you can, and just look how simple this is. 2 routers and a firewall, and you could do a million other things with this. This is just your basic introduction to this. Well, hopefully you enjoyed this video, and please hit that notification bell, please subscribe. I will keep making more videos.